Hi. So we're recording today from my upstairs room in my house, and I'm going to be going over some electron configuration stuff, some orbital diagram stuff. You'll notice we have like a much fancier setup. We have like the screen up there, or wherever, over there. My name is down here. How fancy is that? Wow. Yeah, it's amazing. Um, But no, so the point of all this, we're going to talk about electron configurations today and orbital diagrams. What I want to do to begin with is just sort of like review some of the really basic stuff that we've covered, that you read about. I just kind of want to talk about it for a little bit, and then we'll get into like the actual problems and everything. So to begin with, this is just sort of review, then we'll get into the actual problem solving stuff in a minute. So first, remember that we've got orbitals, and we're talking about like where an electron is, where it can be found anywhere in the nucleus, or like where an electron can be found anywhere in the energy levels, like exactly where it is. Now, some stuff from the lesson that you guys did last week. All right, so a few things here. I'm going to be writing them here first. This part here. Yeah, it's good. So, basic idea is this. Remember that we have four. We have like four major sublevels. So we have the S sublevel. All right, so these are sublevels. So we have the S sublevel, we have P, we have D, and we have F. Those sublevels are made of energy levels. All right, so the sublevels are made of energy levels. And as far as remembering, how many, the energy levels are made of sublevels. Those sublevels are made of orbitals. Now, remember, the orbital is that three-dimensional shape. So the orbital is this three-dimensional shape, remember. The S orbital is like a sphere. The P orbital is kind of like this dumbbell-shaped looking thing. The D orbital it's like they're really goofy. There's a lot of them. And the F sublevel is even goofier. You don't need to remember the shapes of the D or the F. You need to know that S sublevel is a sphere, and that the P sublevel has this sort of dumbbell shape. Okay, that you do need to know. Beyond that, though, let's review how many orbitals they each have. Now remember, the S sublevel has one orbital. The P sublevel has 3. The D sublevel has 5. And the F sublevel has 7. So that's how many orbitals they each have. Now, remember, how many electrons can any orbital hold? So all orbitals can hold 2 electrons, no matter what. That's it, max. That's all they got. 2 electrons. All right. So we're going to remember that. And then remember, even to be even more specific, certain energy levels only have certain sublevels. So like the first energy level, so if you want to go even over here, so like the first energy level, and this is all from the chart on that electrons address worksheet. The first energy level, it only has, I spelled level completely wrong, it only has the S sublevel. The second, that has the S and the P. The third is S, P, D. Fourth is S, P, D, and F, and so on and so on and so forth and so forth. So, this is just sort of broad, basic ideas about all this. Now, as far as, just review, that's good. Let's review a few more things now. So, or I guess this will kind of be getting into new stuff. So the idea here, what we're really going to be doing today, we're basically going to start talking about all these things abstractly, where it's sort of just been like, hey, like we're just talking about this stuff. We haven't really gotten into any of like the specifics yet about how we're actually doing this address, but now we are. So the idea here is that we're going to be putting everything together. We are going to be diagramming out all of the electrons in an element. Simple as that. Now the way you're going to diagram them all out is using a certain notation. All right. So it's using a certain notation. And that notation, it's got 2 names. One is an orbital diagram. 2 is an electron configuration. But the notation, it looks something like this. And you'll notice that we're writing like, oh, like a 1s, and there's a dash above it. And you're like, what is the dash? I'm like, what is the 1s? And There's a lot to it. And then you have 2s, and it's like, oh, I don't know what that is. Maybe though it makes sense now because you're like, oh, well, the first sublevel or the first energy level, it just has an s sublevel. So maybe that's 1s, maybe that's the first energy level, first sublevel s. Then over here you got the second energy level. It's got 2, you know, because that's the energy level. Then you have an s because the second energy level, it has an s. And then you also have a p. Second energy level has an s and a p. So maybe 2p. It's the second sublevel or second energy level with the p sublevel in it. And these dashes up above it. These dashes are like, what are those? Well, those are the orbitals. S sublevels have 1, P has 3, S has 1, P has 3, etc. We'll talk about it. Don't think that you have to understand this yet. Now the big thing is that there is a very specific order of energy levels that everything follows. So there is a very specific order of energy levels that all of this follows. And that means that like everything, you know, there's 1s, then 2s, then 2p, then 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, blah, 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 blah. There's this whole order of it. And you might not want to have to memorize it. And I wouldn't blame you if you didn't, because honestly, yeah, most people don't want to. So instead, it's really cool. There's this thing called the periodic table. You've heard of it a little bit. We've talked about it a little bit. And the periodic table is very nice because it lets you look at this and it tells you, it actually tells you the order of energy levels that you have. So this shows you, and if you actually just sort of follow along with it, it's pretty cool. So let's see if this actually works how it's supposed to. Kind of. So this is not the world's prettiest. I don't like how it's the aspect ratio is a little off, but whatever. So the point is though, in looking at this, if you now start over here with like 1s, like, and you just trace along on the periodic table, you will basically now be able to know the order of energy for anything you encounter. All right. So what I mean by that is basically, all right, let's say we wanted to figure out whatever, you know, this element here. All right, whatever it might be, doesn't even matter right now. Like, what's the order? So you're going to go, oh, it's 1s. Okay. Oh, look. Then you go back to 2s, and then it's in 2p, and you stop there. And that's the whole configuration. Now, it can be a lot longer than that, obviously, and you can just keep tracing and tracing and tracing, and it's quite useful like that. So that's what we're going to be looking at. Now, as far as like actually putting this all together, notation-wise and stuff like that, let's talk about that for a minute. So the big thing here is this slide, this little bit here. This is important. All right, this is definitely important. Oh, look, that zooms in way too. So the idea here, the importance of this, is that it tells you exactly what you need to know here. So you're going to be putting in arrows. You're going to be drawing dashes. Those represent the orbitals. And the arrows represent the electrons. And the up or down represents the spin of the electron, which we're just not concerning ourselves with. But all we need to know is that the spin basically is just a way of differentiating between electrons in the same orbital. So one is up, one is down, always. Don't worry, again, though, beyond that. But that's the deal. So we're going to draw dashes for orbitals. We're going to draw lines for electrons. And we're going to put the arrows up and down. And those will represent all the electrons in an element. Now to do this, there are 3 rules that we need to follow. 3 rules. The first one is the Aufbau principle. Now, the Aufbau principle, it states pretty much this, that when you have, so let's say you have, you know, some amount of electrons. Well, when you're filling in electrons, you're always going to put the arrow in the lowest energy sublevel, the lowest energy orbital that it can fit into. So like you got 1s, you're going to go like, oh, okay, the arrow's going to go in 1s. Cool. Now, let's say I want to put in another arrow because I have another electron to add. Well, each of these dashes represents an orbital. How many electrons can every orbital hold? And you're like, oh, it's 2. So where's my next arrow got to go? Is it going to go into 1s, which is the lowest energy sublevel? Or is it going to go into 2s, which is the next lowest energy sublevel? Well, this is the confusing part some people have. They think, oh, well, it should go right here. But no, that's wrong. It should not go there. All right, instead, the arrow should go in 1s, pointing downward. Because now the 1s sublevel, now it's filled. Because, you know, so you got to view each sublevel kind of as its own deal. All right, so like 1s, it's got 2 electrons. Now it's done. Now you can move on to 2s. Let's say you want to put 2 more electrons into 2s. From now on, I'm just going to be drawing arrows like that. I'm not going to put the double arrow because it's a pain in the butt. And this is a lot faster and it saves time and it takes up less space. Trust me, by the end of this lesson, you'll feel the same way. So I'm going to fill up 2s, put 2 electrons in there. Cool. Now, 2p. So here's the deal now. So this is where it gets confusing. So let's say I put an electron there. Now I'm going to put electrons in all of these, and I'll explain why. And you have to fill up each of these with 2. It's kind of hard drawing with the mouse. Before you can move on to 3s, then 3p, then 4s, then 3d, etc., etc., etc. All right, that's the deal. So we've got that. But remember, the Aufbau principle in simple form, though, again, lowest you put the electrons in the lowest energy sublevel that they can go into. Next we have Hund's rule. All right, Hund's rule is its own deal. I used to convince kids that this was named after Attila the Hun, and they would be like, "Really?" And it's like, "No, fool! Like, no. Attila the Hun was not a, theoretical physicist doing stuff with electrons." But whatever, kids are gullible. So no, this is not. It has nothing to do with Attila the Hun. But the idea here with this one is pretty much that you have you've got your stuff. So the 1s is filled up, 2s is filled up. What Hund's rule basically says, this is a fancy way of saying it. It says orbitals of equal energy are each occupied by 1 electron before you double up. So in fancy terms, or in simple terms, what this means. So you never are going to put an electron in an orbital, and the orbitals in this case are boxes instead of dashes. Like, it's the same thing. It's a dash. It's the same thing. Okay, don't think that it's not the same thing. All right, it's the same thing. But the point is that we're filling up these orbital deals here, and you will never put an orbital or an electron in an orbital like this. Why? Because there's an open spot over here. Think about it in terms of your parents bought a house, and there's 3 brothers and sisters, 3 siblings, and the parents are like, all right, we got 3 bedrooms here for you people, for you children. You want to sleep in, you can pick your own room. All right, first kid picks this room. Cool. Second kid picks this room. Third kid, realistically, probably going to pick their own room. Why would they double up? Why would they choose to go over here unless they had to? No, they're going to have their own room. They want their own space. Electrons want their own space. They repel each other. They're all negatively charged. They hate each other. They want to be as far apart from each other as possible at all times. So it's going to go over here, and it's going to be its own deal. Only later then. So let's say I had another one to put in. Only then do you go back and double up. And you keep going. And that's Hund's rule. All right. So let's keep going. And finally, we have the Pauli exclusion principle. This is a lot of stuff here, and in reality, all the Pauli exclusion principle says is that you can't have 2 arrows pointing in the same direction in the same orbital. So it means that you will never have 2 electrons like that. No. Instead, you'll just always have an arrow pointing down. To keep with the analogy of the bedroom and the house and stuff, it'd basically be like saying, okay, like the parents like, no, we got another kid now. We got to put another arrow in here. No choice. But we have bunk beds. One of you can sleep on the top bunk facing up. One of you can sleep on the bottom bunk facing down. Cool. Generally, siblings are not going to be like, yeah, no. We're going to face the same direction. We're going to sleep in the same bed. That's just a little weird. That doesn't really happen because you're like, my brother smells. I hate my brother. Your sister, you're like, no, I'm good. They smell. They're annoying. They're going to hit me or whatever. And that's just how it goes when you're siblings. So you're like, no, I want my own space. I want my own bed, whatever. That's the way this works. That's a Pauli exclusion principle. So all of that adds up to basically that's the general way we're going to do this. All right. So I'm gonna actually sort of stop the recording now in a minute. I'm going to stop it now, and then I'm going to start a new one that'll show you example problems. I want to do them separately. So we've got the theory, we've got the notes, like this basic idea. And remember, again, we're looking at all this. So for an even more review, so the S sublevels, to go back up here, there's 1 orbital for S. P is 3, so you would have 3 dashes. D is 5, so you'd have 1, 2, 3, 4, 5. And then F would be 7, so you'd have 1, 2, 3, 4, 5, 6, 7. It gets kind of ridiculous. We're not going to really do too many elements with the F sublevels because it just takes a lot of work and it's just like excessive. And you're kind of like, nah, I'm good. Here, I'll move this over a little bit. So we'll do 7. We'll move it over so it looks better because crossing it off obviously looks a lot better. And then let's see, anything else that you might want to know. So yeah, the only other type of thing, so if you see something written, let's say you see something written like this. You see like 3P, and then it's got like, you know, so just sort of like a legend or a key almost here. So this number here, this is the energy level. This is the sublevel. These are the orbitals. And then if you were to put electrons in here, look at how neat that is. Those things, those would be the electrons. Now to answer a question, the number of dashes does not correspond to this number. All right, people always think this. The number of dashes does not correspond to the number. It corresponds to the letter. So whether you have 3P, 2P, whatever, the P sublevel always has 2 dashes. So if you were to write this out again, 2P, it has 3 dashes still. Why? Because P sublevel. Second energy level doesn't matter. The P sublevel. All P's, 3. All D's, 5. S is 1. F, 7. All right? So that's the basics. We'll do some examples in a second.